technique. This is a static electricity. See, we have a pole here. When we rub this to the silk cloth, this will gain the negative charge and this will gain the positive charge, and see, here it will get attracted to the bubbles present inside. This is electroscope. How the electroscope works. First, this is a gold leaf electroscope. First, what you have to do in the sense, there is one glass tube with a silk cloth. Just rub it over and place it on this top of that. At that time it should show the deflection. See, you can see that the gold leaf deflects. And this is when lightning strikes. See here, in the sky and all, lightning and thunder you might have seen. See how that lightning occurs. This is how the lightning in the sky occurs. This is the mechanism of it. This is a Doppler machine which is invented by August Doppler. Tank for electric charge. This is the wave of charging and this is the way of discharge. See, this is a charge and discharge. See, you can see the deflection here. See, discharge. Here also the same way, when you charge it, see, this will also turn, and when discharge, it stops. See, it compresses, and when discharge, it expands. The virtual EMF. There will be a battery with positive and negative signs of anode and cathode, and that will be connected to a bulb, and how the electricity is produced. Hand battery, this was actually invented by the Luigi Galvani, an Italian scientist. See here, as we place our hand here on the metallic plates, you can see the readings here. See, here our hand and both this metallic plate acts as a battery. This is a Volta's pile where the silver discs, cardboard soaked in salt solution, zinc discs are being piled up here. These are the batteries. See, you have the batteries here. So you have here Daniel cell, dry cell, battery 6V, different types of cells are there. An electrical voltage. As we press this button here, see, you can see the deviation in voltage and also in ampere. And even the bulb also lightens. This is all about AC or DC, means alternating current or direct current, where alternating current moves in an alternative way, but direct current moves in a continuous manner. And ohms. When we have an electric circuit, we should have a voltmeter, an ammeter, and also a resistor, and that is measured by voltage, amperes, and even ohms. This is a voltmeter, an ammeter. This is a resistor measure, ohms. This is less current and thicker wire carries more current. Now let's see the demonstration of it. See, the thicker wires, it will carry the more current, whereas the thin wires carry the less current. Different currents here. So this is a live wire with this red in color, and this is wire B, black in color. And you can even see the readings in ohms. See, for different wires of different readings. Electrical circuits. See, here we have two wheels, and whenever we rotate both the wheels simultaneously and leave it, the second one will stop earlier than the first one. The reason why is because the first wheel, it contains a ball bearing, but the second wheel, it contains only the plain bearing. So the second wheel will stop soon compared to first wheel. So you can see now, I'll show demonstration now. See, it stopped fast than this because it has plain bearing. The losses in electric circuits. See, when you press the switch A, the bulb glows brighter. But when you switch the second button, there is a loss of current there. See, you can see now. This replicates the loss of electric current. See. Oersted's experiment. In these experiments, you have here a magnetic needle and you have two switches here. And when you press the switch 1 or A, this magnetic needle will show deflection in one direction. Okay? And when you press the second button, that magnetic needle will show the deflection opposite direction of the first switch. This is Barlow's wheel. See, there's a demonstration here. You have two switches, which is A and B. Current is flowing downwards, whereas the wheel rotates forwards. But here, when you press the second button, the current flows upwards and wheel is oppositely directed. So there is a coil which is suspended in a magnetic field. So this is a magnetic field which has a magnet here, an horseshoe magnet, and when we press this first button, you see the current flows upward and this coil is attracted to the one pole, but when we press the second button, the flow of current is downwards and this coil is attracted to the another pole of the horseshoe magnet. Magnetic field around the conductor. Conductor is placed and around it a magnetic field. How does it work? See the demonstration. Here you have two switches. When you press the switch A, the current flow is downwards. At that time, all the compass needles show a deflection in one direction. But as you switch to the second button, the current is flowing upward and the compass needle deflects in another direction. See, this direction. This is the Faraday spring, where two coils are bound together in an iron ring. See, when you press this, you can see the deflection in the voltmeter, the DC current which is passing through. Faraday's continuous motion experiment. There's a demonstration. When you press the switch A, that the motion will be in a one direction, but when you press the switch B, it will reverse the direction. So this is a demonstration of how to produce electricity by moving a coil. See, there is a coil. Generator is basically which converts the mechanical energy into electrical energy. Now I turn this coil so that, see, you can see in that meter where the current is produced. That is a device of ammeter off or measures the current. So demonstration of idle power. Idle power is much similar to hydroelectric power, where the power is generated by the water power. See, I'll show you the demonstration. See, you can see there. Wind power, how the power is generated through winds. See, the hair is coming out through this. When you press this button and switch it here, see, the power is generated. A biomass power plant demonstration. See, when you press here, biomass is something which will be produced by a biological waste such as cattle wastes and vegetable wastes and all. Fuel cells, a solar model. See, as you press this switch, a solar panel which is being heated, and see, the charges keeps moving. It will fill the fuel cell of the vehicle, automobile. Geothermal power plant. Geothermal is basically where the heat from the earth is used to produce the electricity. See? So 300 degrees Celsius, as steam is taken in through turbine, it produces electricity and is supplied to the homes. And the water, cold water is left inward. A solar car, a solar electric car. You can see a solar panel which is fitted upon the car, which absorbs the light energy, and that solar panel will convert that solar energy into electrical energy, which helps in the movement of the car. Solar power, how the power is generated by the solar energy. See, the solar panel gets heated, so that this is a solar cap, a solar calculator, solar mobile charger, and see, this is all about solar power. So this is how in the villages the solar energies are used. Demonstration of a village with solar panels. Transmission and distribution of energy. How the energy will be distributed to all the industries, houses and all. A miniature circuit breaker. What in homes and all we will be having the MCBs, right? That MCB is only miniature circuit breaker. Demonstration of a motor. Motor is basically a device which converts the electrical energy into mechanical energy, which we use in fans and all. So we can talk also even by using electricity. So let's demonstrate it. Telephones. Different telephones of different eras. Crossbar system demonstration model. Here we have different types of telephones. So here we can see different types of cables, the multi-core cable, multi-core shielded cable, VGA, video graphics array cable, fiber optic cable, SATs means category cable, coaxial cable, different types of cables. Transformer. There are two types, step down transformer, step up transformer. generator. A generator is basically which converts mechanical energy into electrical energy. I'll show you the demonstration. Milestones in electricity. How electricity developed, how it came into existence, what the scientists who are responsible for this. Electricity used for different purposes. Second generation computer, IBM company America, 1401. IBM 1401 CPU. Thermal power plant. This is about the thermal power plant which is produced using coal. See, first of all, this coal is being crushed like this, and this coal will be transferred to the burner furnace, boiler furnace. In boiler furnace, what happens in the sense? This coal will be burnt out and it produces the heat, and that heat will be used to boil the water, and the steam which is produced will pass through the turbine, and that turbine rotates and produces electricity here, and that electricity passes to all the industries, home, everywhere. Plant model. Actually, a nuclear power plant has uranium. This uranium, when bombarded, it produces lot of heat, and this heat is used to boil the water to produce the steam, and that steam is used to rotate the turbine, and the electricity is produced by the heat. This is a raising arc demonstration. The discharge of high voltage. Here are conductors and insulators. Conductors are something which allows the electricity to pass through it, but insulators inhibits the passage of the current. See, this is a wooden thing and this is the glass one. These two are insulators which does not allow the electricity to pass through it. I will show you the demonstration. See, there is no changes if you insert this, even this also. But these two are the metal ones, and this will produce the electricity. See.